everyone who registered webcast, but please feel free to type in the Q&A whenever you have one. It's located to the left of your webcast console and can be hidden or pulled up using the button at the bottom. Okay, let's get started on today's webcast. My name is Emily. I'm a content marketer at GitLab, and joining me today is Victor Wu, our discussion product manager. I'll start with a quick introduction of GitLab. Then Victor will discuss the business importance of code review, share some best practices we use at GitLab while both using and building GitLab, and talk through how new coding practices are reshaping organizations from the bottom up. Finally, we'll close the session with a Q&A, where we'll be joined by additional team members who can answer all of your questions. GitLab is the integrated platform for the full software development lifecycle. It's built on top of Git, the leading version control system. Git allows developers to store a local copy of their source code, propose changes to it, and share those changes with others. We help you create great software by strengthening and integrating your source code management, code review, testing tools, and deployment process in one platform. Experience across the development lifecycle helps increase developer productivity by reducing the number of times your developers have to switch from one platform to the next. This ensures everyone on your team is more productive and more collaborative, providing the most efficient approach to software delivery. And now I'll turn the floor over to Victor.
Hi, everyone. So today we're going to be talking about code review, and in particular, we're going to link code review into business goals or business objectives. So hopefully a lot of you on the call are involved in building software, or you're perhaps a product manager, a business manager, or maybe you're an engineer. Somehow you are involved in the software development process. So I'm excited to be chatting about some of those things here. So we're going to get into what is code review, why is code review important, and we're going to link it up to code quality, which is a related concept. We're going to talk about some code review best practices, and finally we're going to wrap up and talk about what we do at GitLab. So code quality is a business concern. That's the underlying theme of today's chat. Good code is not an end to itself. So when we talk about code review or code quality, we're just saying something that's a good piece of code. So we're not going to get into details today about what good code is or defining good code or what is quality code. But suffice it to say, if you have a bunch of software engineers in the room and then they look at the code and say, that's a good piece of code, then we'll just say for the sake of argument that's good. And the reason is because we're not going to get into the details of the different language frameworks and technologies and whatnot. So similarly to an architect or a civil engineer, they get together, they look at a house and they say that's a good building, that's a good house. We're not going to get into the details of all the kitchen cabinets, the floors, or the structure. We're just going to trust them and say that they looked at the house and they said that's a good house. And we're going to see how that impacts your business. And why that's important today is that every business is a digital business today. Whether your business is fueled by technology, it is driven by technology. For example, maybe technology is the main innovator or business driver of your company because you have some proprietary technology or software, hardware, or perhaps you have a feature set that's very original. That probably means that technology is driving your business. Or the reverse, maybe your business model or the type or the way you interact with customers, your operations is the business driver in that sense, but still technology needs to support it. So that in any of those situations, your business is a technology business. So that's why it's important for all types of business to understand technology and in particular software, because software is increasingly becoming a differentiator over, say, hardware. So the benefits of quality code are fairly obvious when you look at this slide that you see in front of you. Keeping a clean code base, building out new features, making sure you ship those features more quickly into the marketplace, reacting to changes in the marketplace, and of course, having that stable and predictable code base so that whatever happens is something that you expect. So these are pretty obvious. It's something that any business desires, right? You want to move quickly, and you don't want to surprise your customers in a negative way, right? You don't want them to suddenly lose all their data. You don't want them to encounter defects in your application. You certainly don't want to scare them away with a screen that says, all your money is gone, or your health insurance is suddenly no longer available, or you're past due on your loan even though you've paid it off already. So these are things that are very important to your customers. And with code review and maintaining that good quality code, it has that direct impact to your business. So we're slowly linking the thread of quality code and code review to business benefits. But let's get a little bit closer into the weeds and what we mean by doing that. And to do that, we have to consider what are the costs of quality code. So it's all great in a perfect world to have great code, but in reality, as I'm sure you experience day to day, it's not that easy, right? There's a lot of trade-offs, and a lot of times we can't ship that perfect piece of code or that perfect application, or ship something that's 100% without defects. And why is that the case? So there's a number of reasons, right, that I'm sure you've all experienced in one way or another. Maybe you're working in a smaller organization and you just don't have the talent. You don't have the engineering resources. You don't have the experienced lead engineers, maybe because you can't afford the lead engineers, or maybe your company is too small that you can't hire the effective HR folks to recruit for them. Maybe the type of business you're in is not interesting to engineers, or maybe your culture is not interesting to good engineers. So there's a variety of scenarios where it might be difficult for you to attract the talent, to retain the talent for a variety of reasons. And those are all costs, right? Because to create that environment to attract and retain that talent is a cost to your business. And so if you, that ultimately is the sort of long-term cost of a quality code. If you want quality code, good code review, you need the people to do it. You need the human capital. You need the resources to achieve that. Beyond the human resources, sort of on a short-term scenario, day-to-day, maybe you want to ship a feature as quickly as possible, but your engineering organization, the software team says, no, I need additional time. I need more effort to fix something up. There's this defect that is causing some trouble. I want to fix it quickly. So to maintain that quality code requires not only the good engineers, the senior engineers, but it requires time. So time is another resource that you have to contend with. It's another cost. And if you want to get even a little bit more esoteric, some of you might have heard of the maxim or the fact that if you keep adding more engineers to an existing problem, it's not necessarily going to solve it faster. So sometimes you've already reached that bottleneck, and just adding more manpower to it will not resolve the feature. You can't kick it out as soon as you would like. So these are the inherent costs of quality code, and of course it's about people and resources. Ultimately, that's dollars and cents for a typical organization. And then some of the things that are harder to quantify might be the culture, staying disciplined, and so on and so forth. Again, those are harder to quantify. Maybe you can spend a little bit of money to enable those things, but those are all costs. Those are all resources that are required to maintain that quality code. And I'm sure many of you have experienced that. So bringing it back to very, very close to us, or maybe your organization, how does that play out in your organization? So if you work in a larger organization, and I use the term large or big with a caveat, it might not manifest itself day to day, because you might already have some strict processes for good code review, and that's great if you're in one of those organizations. You might have a team of experienced engineers. You might have a formal code review process, approvals process to sign off every request, a merge request, we call them at GitLab, into the master branch, or maybe you're reviewing every single line of commits maybe there needs to be a lot of review for every single feature, every line of code. So that's great if you're in a big company and you can afford that. And then not only in big companies, in certain regulated industries, this is very important because you want a stable product, you want to have satisfied customers, and you can't afford to ship something that is not working. So if you're in healthcare, if you are in finance, if you are in other regulated industries, if you ship a piece of software that is broken or causes a lot of harm to your customers, that's a huge business risk. If you get sued or if something terrible happens to a customer, that could be the end of the day for your business. So that's something you obviously don't want to have. So for a big company, chances are you are investing a lot in code quality already. You have a strong process, a stringent process to do so. So whether it's for security, for good performance, for shipping a steady pace of features but not too fast, you want those satisfied customers. And chances are you are maybe a larger company, you're an incumbent in the space, you have a steady revenue flow, you can afford that quality code, and you can afford the code review process. And so in this scenario, 90, 95% of the time, there really is no reason why you should skimp on code review or a good review process. There's really no reason why you shouldn't take the extra time to make sure that you ship a quality product because of all the high risks of screwing up, essentially, and all the resources that you already have at your disposal. Now, don't get me wrong. I know in large companies, of course, there are demanding requirements and timelines as well. But a lot of times, if you analyze it from a broader perspective and a risk perspective, there's really no reason to try to go too quickly. Now, compare this with a smaller company, and again, we use small just as a catch-all here. A small company, maybe a small startup, a company just getting off the ground, maybe with just a little bit of funding and not a lot of runway. But again, a small company, again, I say small with caveat because some small companies are playing, in the healthcare space, the finance space, and other regulatory industries, like I mentioned before. And for those companies, their additional cost is, again, shipping quality software, at least in the pieces where it matters, right? For, health records or insurance and so on and so forth. But the interesting thing with small startups is when you do need to take some shortcuts. And for the engineers on the phone or the engineering managers on the phone, you might be cringing and say, why would I ever ship, poor software? And so the reason I argue from this perspective is that if you are not competing and you're in a small startup, with whatever software you ship, that is what you use to compete with your the incumbent in the space, other startup competitors. So say, for example, you are working on a piece of software and you want to get it perfect. You want to get 100% perfect. You want to iron out all the reported defects, and you do so. But it takes you that extra, 2 weeks or even a month. And in the interim, your competitor releases another product and beats you to market, and they acquire all the customers. Great, you have an awesome piece of software, but you've just lost your business. So, and that totally defeats creating the software in the first place. So if you have a perfect piece of software, but you have no business at the end, then there's really no point to all of that. So what can you do? What should you do in that scenario? And of course, the popular term is tech debt, incurring some technical debt. So that means not shipping that perfect piece of software, not building that perfect building, and putting it in the marketplace for the express purpose of achieving those business goals. So those business goals may be getting customers, getting some feedback in the product marketplace as soon as possible, beating your competitor, maybe experimenting with a certain feature with a small set of beta users, just trying to push something as soon as possible out in the marketplace. And as you all know, with technical debt, as in all types of debt, like financial debt, it's a very delicate game. So an analogy is when you take out a loan, a personal loan or a business loan, it's an investment. If you take out a business loan, or sorry, if you take out a personal loan, say to buy a or to go to school. So say you take out a college loan. It's an investment. You pay it back at the end after school. And it's a great investment because now you have education and you can pay it off. So if you didn't take out the loan, you could have gotten education in the first place, but now afterward you pay it off. But if you don't pay it off, the loan gets worse and worse, interest accumulates and so forth. And same with exactly with technical debt. So if you don't pay off that technical debt, your code base gets increasingly bad. It becomes a lot harder to build features on top of it. And ultimately, you're actually less competitive because you slow down, you have more defects, and so on and so forth. So it's that delicate game of how you ship something that maybe is not 100% perfect in terms of code quality and feature set, but pushes you forward a little bit in the business goal sense. But the next time you ship an iteration, are you spending the time to repay that technical debt? Are you going back to repay it and to fix up the problems that you created in advance? So you made an investment with the debt, but now you have to pay it back. So that delicate conversation is very important. Engineers understand the concept of technical debt, but are the business folks in your organization, are the engineering decision makers, are they coming together to the table to make those decisions and collaborating and communicating? And my contention and my experience is that often does not happen to the detriment of your organization. And that's something that is really at the thesis and the heart of today's chat. So with this slide here, what I really want to drill down is to say that at the end of the day, we want to be less combative and more collaborative. So collaboration is a buzzword, but it's something we truly believe in here at GitLab. And ultimately, it stems from, or at least the combative part, and the fact that our industry is often broken. From this perspective, it often comes from some legacy problems. So software engineering is relatively new. Software is a very new industry. Businesses have been around forever, but software is a very new industry. Maybe 50 years, where it's been really commoditized, and all businesses use and need to use it, as I mentioned or alluded to earlier. And so software engineering, the industry, at least how it's used, comes from a history of project management, and project management in the old days was originated or innovated in the context of big projects. So in the past, for smaller projects, you didn't need to quote unquote project manage because everything was very simple. You could just figure it out with a small team. But when you're building big industrial projects like building a bridge or a building, you can't really screw up because lives are at stake. A lot of dollars are at stake. A lot of people's livelihoods are at stake. And so with those scenarios, you need some very strict processes. And that's how project management as a field and industry arose. And when software came into being, those software management development processes was based on that fact. So essentially, we, as you may have heard of, software was first evolved from a waterfall approach. You would have a bunch of business folks defining requirements, specifications, feature sets from a business perspective or a user-facing perspective. Then the folks would throw it over a wall to the engineering organization. They would implement those, provide deadlines and estimates, and implement those per the deadlines. And then the business folks would come back, look at it, and then maybe say, this is the next round of features I want. And obviously, with this sort of style of waterfall approach, it's very strict. It doesn't encourage collaboration at all. It encourages a lot of building up of barriers and throwing things over the wall. And as a consequence, the business folks are not really understanding what the engineering folks need, and also the reverse. So you come to this place where the engineering organization says, I really need the next iteration. I really need the next feature set to be all about, cleaning up my code base and refactoring it because that's very important to me. And then business folks say, why is that important to you? I don't really care. I just care about this next feature and moving in the marketplace. And the engineering says, I don't really care about your users because they're your users, they're not my users. I don't care about the market. I just care about my code base. So you start putting up walls and different goals, which is at the end of the day really sad because ultimately the different organizations within your company should be serving one goal, which is to advance the business. So with the advent of newer processes such as Agile and Scrum or Kanban or whatever buzzword or flavor you're using, we're getting to a place where we have smaller teams, smaller sprints as we call them, or iterations, and encouraging more collaboration. And in this sense, it's the right direction that our industry is headed in toward. And with GitLab and code review, we're definitely pushing forward with that. And so that's great. And so I'm sure your organization is in various stages of that transformation. But one thing I wanted to highlight is that even there, you might have some sprints or your organization might say, oh, this sprint is all about refactoring code, or this sprint is all about performance updates. And it's not really focused on the user or the business per se. And so instead, I would encourage your organization to speak in business terms. So if the engineering manager says, there's a lot of tech debt here that we want to repay, and this is the business reason. If we do not clean up this tech debt, within the next 3 months, or maybe even the next month, any future features that you build on top of it will take twice as long. Or maybe an engineering manager says, I really am interested in refactoring this piece of code because if I do so, future features that you want developed, they will be developed in half the time. So to a product manager, to a business owner, when they hear that, they understand it because it's in business terms. It affects directly to the business outcomes. So a lot of times engineers might rightly so be focused on the engineering outcomes, but if we can encourage the engineering organization to communicate and translate those engineering outcomes into tangible business impact, then that makes all the difference in the world. And then conversely, if our business managers are also a little bit more, technology literate and understand that, not everything is possible, and then the importance of quality code is to positively impact their business. That again goes a long way to, establishing trust, forming collaboration, and so forth. So with that said, let's talk a little bit about what we do at GitLab. So at GitLab, we definitely do code review, but we don't have those strict stages that even, definitely we don't have the strict stages as waterfall, but even we go beyond, a little bit beyond, say, Agile or Scrum, where in Agile Scrum, typically you have multiple stages. You have, some features that are in product or in design, and then they're maybe scoped into a sprint, and then maybe a design sprint first, and then afterward an engineering sprint where engineers work on it, and maybe that is further developed or separated into software, and then from software engineering, it goes into quality assurance, and then from there it goes to UAT, where a business person signs off on it before it is shipped to production. So there's a number of stages. Some of those stages might be rearranged. For example, some folks do code review before QA. Some folks do code review after QA. Some folks do it in both times. Maybe some do it at the same time. So it's really different, but typically there are multiple stages in a Scrum environment. Well, with GitLab, we essentially don't really have those strict stages at all, and we almost do all of them at the same time. Don't get me wrong, we still ship monthly and we still schedule issues or we scope them into a particular release and we work on them. But within that 1 month scoping time, or that 1 month milestone as we call it, all our stakeholders are actively working on the feature essentially almost at the same time. So what we do is when a feature has been scheduled into a milestone, chances are it's 80 to 90% scoped out in its functionality. We might have a few initial mock-ups to give us an idea of how it will look to a user, but purposely it is not spec'd to 100%, because if we do so, we're first of all using a lot of resources ahead of time, and we don't want to do that. But we want to encourage collaboration just in time, Toyota style, just in time collaboration. And so with that, what we have is we have designers, we have product managers, we have engineers collaborating within that milestone. So typically we might have a kickoff to quickly highlight our business goals, our user-facing goals, and then the engineers would get to work. Maybe they'll throw up a piece of code, often very quickly, within a day or two. And with GitLab issues and merge requests, we have something called a work in progress merge request in GitLab. And what that does is that a piece of code, a branch, is already pushed into GitLab right away. And then since we're all remote and we work asynchronously, we all asynchronously download that branch to our local machines, and then we run it. Or maybe we run it in an external virtual environment. And so everybody can see that piece of code working. And then the designers might have some opinions, the product manager might have some opinions, and we start chatting asynchronously in GitLab. In the merge request itself, we may say, oh, let's maybe change that button. Let's change the design a little bit. Let's tweak this a little bit. Let's change that color. Or maybe we say, oh, we totally missed this edge case. Do we need to account for that? Or maybe we'll shrink the scope, or we'll expand the scope because our engineering team said that, oh, that really doesn't make sense in this iteration, so on and so forth. And while all that is happening, we're also doing code review, right? Because since the merge request is already online, a lead engineer might peek in, or maybe the designer or product manager who has some coding chops from a previous lifetime or just being in GitLab long enough, we might say, this line of code really doesn't make sense. I remembered something previously. Or maybe if it's so obvious, they'll just make a commit on that branch right away. So in that sense, code review is not really a separate process, but it's just part of us collaborating on the feature. We don't separate it as a code review step, but essentially all within that time period of within that month, we do it all at once. Now, don't get me wrong; it's not very messy and everything happens all at once. There are still stages, but I like to think of them as micro stages. Typically an engineer might spend a day or two getting something that's 80% done. It's intelligible to non-technical folks, and then we can spend the remaining 20% of the feature collaborating hyperactively. And so that really helps us. And so that's why we don't call ourselves Agile. We don't call ourselves Scrum. We don't want to tie ourselves into those boxes because of that particular reason. And so we call ourselves, or we use the term conversational development because we want to emphasize that we are having a conversation. We're collaborating asynchronously in the issue itself. And furthermore, we are not following any strict number of stages that maybe certainly Waterfall would prescribe and maybe Agile and Scrum and Kanban suggest. I would put it that way. But at the same time, I did want to caution and mention that we're not saying conversational development is something that everybody has to get on board with right now. I'm not being very strict about that and claiming that that is the only way to do software development. To us, this is something that has arisen organically because of our asynchronous, remote, and open source nature, how our product has evolved, and something that we had to not only was it or cope with, but has actually allowed us to evolve truly beyond Agile and Scrum. But at the same time, I wanted to say that GitLab has been designed with those Agile and Scrum best practices in mind. We are creating a tool for users like yourself that are using those processes. I would say less so maybe if you're using Waterfall, obviously GitLab would still work for you. But when we're brainstorming features, when we're chatting with our customers and our users, oftentimes they're following a variation of Agile and Scrum, and we're designing our product around that. And fortunately, those different processes and styles are similar enough that our feature set is often able to capture them. So just wrapping up here, that's why code review is really, we start off with code review and we really expand it out into collaboration. So code review is definitely a very important process. It's one tool in your tool belt as a software or engineering organization to ship quality product. But indeed, at least here, how we've experienced it in GitLab, it plays a crucial role because it is so pivotal in that collaboration process, in that conversational development arena. It encourages a lot of conversations. Oftentimes, as an example, we might look at a piece of code. Somebody might be reviewing a piece of code, and then it sparks a lot of conversations, possibly about different parts of GitLab that we need to fix. So we quickly create new issues and so on and so forth. So code review is, of course, about shipping quality code and maintaining that quality code, but it is also about collaboration and conversational development. So I think that's about it. Yeah, that was the final slide. So I'll leave the remaining time for questions. We also have Regis on the line, another product manager. So we'll take any questions from the audience right now. Emily is going to also do a little bit of mediating and make sure we don't go over time. But let's take some questions here. I'm just going to look at the list here. So give me a second here. And Emily can jump in if there's anything further. So one thing I did, so one question here is about code review and QA. So something that I mentioned just really briefly with quality assurance. So oftentimes QA engineers will review the code, obviously, and they do code review themselves. So I've been in some organizations where QA engineers are just looking at the feature set, and they're very manual. And they don't really look at the code. They just look at the feature from a user perspective, and they make sure everything works. All the buttons still click. You still see all the features. And then they have, quote unquote, scripts that they follow to make sure everything is still working. They do what we call maybe regression testing. And then on another spectrum, we have QA engineers that are writing automated tests and to do a lot of automated testing. So here at GitLab, we actually don't have a separate quality department. We don't have QA engineers separately. And so all engineers are expected to do their own QA. And in the same sense, we don't have a dedicated UAT process. We don't have business managers signing off on particular features. Instead, we all do quality together. Engineers are looking at features from both from a technical perspective and also from a business-facing perspective, make sure everything still works, nothing is broken, and then also highlighting any product areas that need to be fixed. So I have a question here. It says, how is design review incorporated into the workflow, and how does GitLab enable that? So I think that's a great question. So our design organization is composed of a bunch, we call them UX designers. And so different organizations will do it differently. Some organizations will have interaction designers and visual designers and user researchers. We do not have that level of specificity. We have just a flat group of designers. We have a design lead, and then we have also one UX researcher or design researcher that goes out and talks to our users. And our design team is very integrated with our product team and our engineering team. They play a crucial part. And when I mentioned how we do the code review and the feature review and the quote unquote UAT toward the end, our designers are hyper involved in that fact. But our designers are also heavily involved in the initial phases. They are involved in designing the features. They're designing the user experience. So oftentimes, a product manager will say, we have this problem that our users are experiencing. There's this huge pain point with submitting this particular form. How can we solve this problem? So typically, we grab a designer and we work through the problem. We might grab an engineer to talk about engineering feasibility, but we have those conversations up front. We collaborate in GitLab issues, and we talk just asynchronously one by one. And then at some point we decide, this is scoped well enough that we should schedule it into a particular release, and then we get further in the weeds. So to answer the question specifically, there's no, in the sense that there's no quote unquote code review in how we work at GitLab, there's no design review. We do everything at the same time, asynchronously. We create, our designers create mock-ups, wireframes ahead of time. We slice and dice those wireframes to minimize scope because we want to ship smaller features more quickly. And then the design team has input along the way as we finish off the feature. And I wanted to take this opportunity to also mention that we do have these particular roles. We have engineers, we have product managers, and we have designers. And a lot of times, those respective roles are helpful in making decisions because those folks are the ones with the most expertise in those areas. So, as a product manager, I would definitely defer to a designer or engineer for certain decisions. But that does not mean that I, as a product manager, cannot have design input or engineering input, and a lot of the reverse. So designers have a lot of product input and engineering input as well. As I mentioned, we all can and do contribute to code itself, but we all make commits from time to time in addition to engineers. So we contribute all. We don't have strict rules, but the roles are helpful to make decisions and to prioritize our time and to essentially act as a leader in particular features. So Regis, I did want to leave some time for you because you're on the call. Do you want to handle this question here? What should we do as an individual developer to ensure good code quality? Maybe you want to handle that question?
Oops. Sure, Victor. That's actually a broad question, and we could talk a lot about it. But I think one of the best things you could do as a developer is to have a set of tests around your code, basically, such as unit test, of course, as well as a functional test. I think like one of the obvious answer would be to make sure that you have that around your code base, to make sure that what you ship in production is at least tested a little bit, So we do not advocate to have like 100% unit test in your code base, but at least have some kind of good coverage, like 80% or something like that, to make sure that you don't ship something that contains bug that could have been tested, that could have been caught before, much before during the development process.
Great. Thank you, Regis. I wanted to answer this question here because it's really relevant to what we were talking about. Have you ever tried to quantify tech debt in terms of business debt, i.e. dollars? This would be one way to help the business office understand the cost of tech debt. So I think that's a great question that speaks directly to what we were alluding to earlier, in that can we translate engineering concepts and tech debt essentially to business impact? And ultimately, if you can translate that into dollars and cents, then business owners can make intelligent decisions. And for GitLab, I want to answer specifically for GitLab. We're getting there. I think with every organization as it's growing, it's very difficult to answer or to establish that process. With GitLab, we're getting there. We're not ultimately able to translate it into dollars and cents, but we are able to translate it into other business, tangible business metrics or outcomes. And one of them is to say that if I'm talking as a product manager, if I'm talking to one of the engineering leads and say that, let's work on this feature, and then they say that we can't work on this feature yet, we have to work on a dependency, we have to work on this other dependency. And then he also says with that one particular dependency, that opens up the opportunity for 3 other features that we can build in the next release. And that's extremely helpful information because those 3 other features might be totally new market opportunities for GitLab. And if we do that, we can bring, if we decision on that, if we consider that in the discussion, we can bring that discussion to our sales team and our marketing team, and then they can say, oh, that's great, because that's something that we want to chat about at our maybe next conference, or we want to chat about that feature to a potential customer that we want to bring in, and we can tell that customer that, you know, we don't make promises beyond a month on what we ship, but if we equip this information for account managers and they take it to sales leads, then we can communicate with potential customers. This is something that we are strongly considering that we're building. Do you want to join GitLab as a result of that? So this is the type of business outcomes we want. We want to equip our business owners with this information. But at the same time, I do want to have a caveat and say that getting too detailed with dollars and cents is not necessarily the ultimate goal. Even if you can get to that level of granularity, your business people, that might be useful information, but ultimately it might not necessarily be actionable. So what does dollars and cents mean in the next iteration versus in the next 2 iterations versus 1 year out? So we just have to be a little bit careful to understand that in what context. So scrolling through some other questions here. So it says, can we evaluate code from multiple technologies like PHP, Angular, iOS, Android, etc., using GitLab? And the answer is definitely yes. So with GitLab, we are not supporting a particular technology. In a sense, you can say we are technology agnostic. We obviously are building our tool to support software development. And if you look at our mission statement, it's enabling everybody to contribute digital content. So whether that is code or, you know, content or documentation, or in the future it could be something very crazy, we're enabling people to contribute. And in particular with technologies, a lot of software technologies, you know, share similar aspects in code review, whether that's looking at lines of code, doing code diffs, supporting automated testing with our CI and CD feature set that we didn't get into a lot of detail today, but that's something that GitLab definitely supports. So to answer the question specifically, yes, our customers use a variety of technologies. Definitely, we use GitLab is itself, of course, built on Rails, and we have a JavaScript framework on top of that, and we are a web app. But definitely, our users are using a variety of technologies. Newer ones, older ones, they're creating web products, they're creating, you know, mobile products, and so on and so forth. Regis, let me throw this one for you. Will GitLab code review report contain code optimization suggestions? I think this is maybe a question about static analysis, perhaps, and GitLab being a little bit smarter in helping you with that.
Yeah, so that's a good question. We've been thinking about that for some time now. Ideally, we would love to have it, of course, but this is so language dependent, you know. So in Java, you don't do you don't do that at all in the same manner as you would do for PHP or for Ruby, for that matter. So there are technical constraints here for this specific part that are at the moment hard to achieve. So for that reason, this kind of feature is on hold basically until either the technology move forward or we find solutions for that specific problem.
Great, thank you, Regis. Let's see. As a guy, perhaps the audience member who wrote this in can clarify, but I'll just guess here. As a guy who is expected to wear various hats, so is there a special selection process of GitLab? So I'm guessing the question is asking, is there a particular way that you choose a certain number of features or work on a certain number of features and so on and so forth? and scheduling features. So product managers here at GitLab are the main leaders or drivers of the product. In particular, we try to characterize the big problems in the product, which are the market opportunities where our product is headed toward, and we try to solve those problems. First, and we try to prioritize those problems with many input, stemming from engineering. Again, tech debt is often a engineering concern, as it is in GitLab, or maybe we get some input from our design team saying, oh, we really need to fix this navigation, or there's a really poor user experience here, we need to solve that. Our support team, gives us plenty of things to fix, and sales folks, marketing folks. We have a lot of input throughout the organization asking us features to build. And so the product manager's job is to not only take all that input and synthesize it, but we are also responsible for innovating and looking at the marketplace and figuring out what to build next. So product managers are leading that effort. We're tasked with organizing it and communicating that, which is huge for a increasing organization such as ours, and especially with our remote and async nature, communication is very key. So product managers are tasked with that. But at the same time, I wanted to emphasize again, get back to our mission, everyone can contribute. So we talked a lot about everyone can contribute to the specific goal of getting a feature into production today. But also here at GitLab, everyone can contribute means also everyone can bring up an idea, whether that's a very small feature improvement or just a small iteration, everything to as large as a brand new initiative, a great, awesome new market opportunity. Anybody can go into GitLab and propose an idea, and we ping each other, and if it's a good idea, if there's engenders a lot of discussion, the idea will naturally surface or organically bubble up. We'll argue on the issue, and then we'll have a lot of good discussion. And then if it is a good idea that stands on its own, it will eventually make it into our process, and we will ship that feature, and that's a great process. And we really value that process, that everyone can contribute. And not only is everyone at GitLab can contribute, we have a very passionate community that sends in plenty of feature requests. We have a community that contributes a significant portion of ideas. They not only contribute to the open source project in terms of code, but we have a lot of issues that are created by folks outside of GitLab, and we don't see them as separate ideas that are from the ones that we generate. In fact, a lot of the features that we ship, if you look at GitLab.com and you look at our CE project, a lot of the issues, and you look at the issue creator, those folks are actually not GitLab team members. Those are folks from our community who have used GitLab or have really great ideas and say, I want this idea, or I'm feeling this problem, please solve it. And then they're actively engaged and they're passionate about it. And then, of course, we bring it back as product managers and engineers and designers, we bring it back into the GitLab context, but it's very important for us that we leverage feedback from the community and idea generation from the community to do so. So bringing it back closer today, question is, in addition to GitLab, what other software, if any, do you use to facilitate conversational development? That's a great question. GitLab's product position and part of our strategy is to provide an integrated platform, a single solution to do essentially get your idea from, when you first have the, proverbial light bulb idea and get it as quickly as possible and shipped into production in front of their users. So our goal is to have GitLab as one standalone platform to support that. And so that's why with some of our competitors, you see a lot of plug and play things, and you see a lot of integrations, and you see a lot of pieces that require system admins to hook everything together. At GitLab, we ship one unified product that can do everything. And that is our product position and strategy. Given that, there's still a lot of things, we can't build everything all at once, so we do allow integrations into our product. And, there's some pieces of collaboration that we are just not ready for yet as a product, or is just not realistic, maybe even in the medium or long term. And one obvious one is chat communication. So internally at GitLab, we use Slack, and for example, in my day-to-day work, I primarily use Slack and GitLab. And that's literally the only tools I use day-to-day. Obviously, when I'm digging into more technical things, I'm using stuff on my machine, SQL editors and, whatever IDE to do local development. But to do the daily collaboration, it's primarily GitLab and Slack. And we really rarely actually use email, which might be surprising for many. We have very little email communications because our entire discussion, whether it is features or actually more, internal GitLab operations, more HR things, some things that we can't share widely with the community. We try to share as much as we can, but more HR things, we still use GitLab.com even with our HR processes. It's just some things might be private. And as a consequence, we have actually very little email communications. Obviously, we use email as a way for GitLab notifications to come through, but very rarely are we typing email communications to each other. We collaborate as much as we can on GitLab itself. It's worked very well for us, and it enables us to be transparent, and anybody, and again, coming back to everybody can contribute. If me and say Regis are chatting about an issue and we decide it's a good idea, we want validation from other team members, we can easily share the ongoing conversation that we've had in the GitLab issue more broadly, and then other folks can chime in, and then we don't have to repeat ourselves, we don't have to summarize things over and over again. They can reread our conversation that we've already had. So that's another very powerful thing with collaboration. So Regis, do you want to take this one? Can I automate code review with GitLab, and can it be integrated into a CI tool like Jenkins?
Sorry, I was muted. So, of course, you can automate, you can integrate your CI with Jenkins. It's totally possible to do that. So, regarding the automated code review within GitLab directly with GitLab tools, like built-in, we have nothing to do that. But however, you can either integrate with Jenkins, for instance, or if you know how to set up CI and script everything yourself, you can do it as well.
Great, thank you. Thank you, Regis. So Emily, how much time do we have more? I want to check in with you.
Yeah, thanks everyone for your questions. I think we probably have time for one or two more, and then we'll have to wrap up.
Okay, great. Actually, Regis, did you want to talk a little bit more about CI/CD? I see a couple of questions there regarding CI. I know today was focused on code review, but there seems to be a little bit more interest there, and I don't want to shortchange folks here. So do you want to chat just a little bit about how our code review, maybe how our merge requests, seamlessly integrate to our CI platform as well?
I'm not sure I'm the right person to actually answer that perfectly, unfortunately, Victor.
Yeah, no problem. Let me just comment on a couple of things there, because there's a couple of questions that are related to that. So I just want to answer it essentially all at once. So with code review, we've been focused on reviewing the actual code and the collaboration and the people leaving comments in the merge request. That's the main object we use within the GitLab platform. But as many of you folks have been asking about automation and tests and so on and so forth, our CI/CD framework, our continuous integration and continuous deployment framework, is tightly integrated into our merge request object or framework itself. So what we do at GitLab and what many of our customers also do, as we're checking in code, as we're pushing in commits to the merge request, a lot of automated scripts are running in the background already. And as Regis alluded to, you can simply set this up in our really very user-friendly interface to configure that using some scripts, some YAML files, and from there, every time you make a commit, it runs, the automated tests, these jobs, and then if you configure the environment even further, what we call review apps, you can even ship some of these automated. So once all the automated tests pass, the latest updates are right away shipped to the environments. So whether you have, you've set up a VM or set up something in some cloud environment, you can have those, what we're calling review apps shipped there. And even if you can even configure it to ship directly into production as well. So depending on your needs, whether you're a larger organization and you need a little bit more control, or you're a smaller organization and you don't need that fine-grained control just yet, we do offer that functionality to integrate directly and push stuff into different environments. And then we get a lot of signals back. In the merge request, it says, the builds have completed, the tests have broken, or if the tests have broken, something has, a test has not passed, then we stop the pipeline and therefore the app is not released into XY environment. So all that is already available in GitLab. It's a reason why our customers often like using GitLab, because they don't have to set up a separate, say, a Jenkins or another CI framework, because it's all integrated. And I do encourage everybody to continue to look out at our upcoming blog posts and features, because we do have some exciting new features on the CI and CD front. So we are shipping GitLab 9.0 in exactly a week, March 22nd. And then we have some exciting features there in terms of even more visibility into the CI/CD framework, and seeing as your application is shipped into production, monitoring that so that you can see, is a certain feature working and not working. So we're slowly making inroads into that aspect as well. So I think that answered, I covered a number of good code review and CI/CD questions there. Emily, do you have any final things you wanted to conclude before we wrap up?
I'm just wanting to remind everyone that I saw a couple of questions about the recording. We will email you the recording, so if you joined late, you'll be able to catch the whole thing. Other than that, thank you so much, everyone, for joining. We hope to catch you on the next one.